Let's learn how to break down networks one by one. Scenario number 1. The purchase of Class C IP 216.21.5.0. We need these three locations to connect to one another. Once again, the IP address is 216.21.5.0. The trouble with this is you get 254 hosts, but you only get one network. $254 hosts on one network, but only one network. That's a problem because we have 3 locations. We have numbered the 3 locations, but also never forget the WAN links. We actually need 5 networks, including the WAN links. Every interface of the router is a network. Every router has 2 interfaces. Here you can see in this little small office, home office router, you got your WAN port and your LAN port. Every router has 2 interfaces. You must assign a subnetwork for every one of these locations, including the WAN links. In this scenario, the 3 locations are Arizona, California, and Florida, plus your WAN links. Notice there is no redundant link from Florida to Arizona, vice versa. However, these 3 locations have connectivity to one another. The 3 steps are: determine the number of networks and convert to binary. Of course, the IP address, Class C IP address that was purchased is 216.24.5.0. Second step is reserve bits in the subnet mask and find your increment. The third step is use increment to find your network ranges. We know that we need 5 subnetworks. Knowing what you need is half the battle. There are many ways to figuring out subnets. So we know we need 5 subnets, 5 networks, to satisfy connectivity between the 3 locations. Write up your binary chart: 128, 64, 32, 16, 8, 4, 2, 1. Here we have converted the number 5 to its binary equivalent: 000000101. 255.255.255.0 binary equivalent is 3 groups of 1s, 8 1s. 255 is 8 1s in binary, and 0 is 8 zeros in binary, just as you see here. Something we must know and understand: 255, as you see here in red up at the top right, that represents the network part of the address. So 255 here represents 216, 255 here also represents 24. So everything that's 255 is network. Everything that's 0 is host. This is a network. Here's another network. Another network. Another representation of a network. Here are more computers connected together, also known as a network. Here is yet another network. If you notice, many of these pictures have a picture of a firewall. A network. Here's a picture of a host. Computer. Old school computer, sturdy case, slow processor. This is also a host. Host. Some dude sitting at his host. Host. So think in terms of binary. Whenever you see a digit 1, then think network. If you ever see a 0, think hosts. I need to repeat that, I believe, 1 yet again. Whenever you see 1, that equals networks. Whenever you see 0, that equals host. Whenever you see 1, that equals the network. Whenever you see 0, the subnet mask, that equals host. So we only have one network and we need to create more. That is the goal. How many bits does it take to get to the number 5? Well, you can see here it takes 3 bits. We are speaking in terms of binary, so we want to know literally how many bits. We're not adding 4 plus 2 plus 1. We are looking at the number of bits. So it takes 3 bits to get to the number 5. So the second step says to reserve the bits in the subnet mask. So we know that we cannot get the number 5 with less than 3 bits. So that's what they mean by that. Reserve bits in the subnet mask. It takes, in this case, 3 bits to get to the number 5. 5 is the total number of subnets required. Network bits are 1s. Here we have our decimal subnet mask converted into binary. So what we're going to do here is we're going to give ourselves 3 more bits. Pick up where the 1s leave off and add 3 more 1s, as you see here. Expressing the goal once again, we need to create more networks. Namely, we need 5 networks. It's a bit strange how we came to this point, how we determined that 3 bits were required to make the decimal equivalent 5, and then adding the 3 bits to the subnet mask, as you see here. This is a little strange, but with practice this becomes easy, and this is how you create more networks. Now that we've added these 3 bits, we're going to know what our subnet mask is. We are going to add 128, 64, and 32. Basic addition, which if you haven't done in a while, relied heavily on calculators over the years, you might want to practice. But brings us to 224. So the subnet mask will be 255.255.255.24. Every single device will use this subnet mask. Every single router, every single printer, every single overhead projector, every single NAS device, network attached storage, every computer, everything will use this subnet mask. Here's a network attached hard drive. Has its own IP address. Even smartphones will need IP addresses to connect to the network wirelessly. So That's a key part to the process, but now we need to find our increment. The increment is going to be the lowest network bit. In this case, this third bit is the lowest bit, and this third bit represents 32. "32" is our increment. So this increment will be our network range. Plural, network ranges. So let's write down our original purchased IP address 216.21.5.0 and add the increment. As you can see in this number pattern, you are adding the increment each time. 0, 32, 64, 96. Each one of these numbers seen here is the beginning of each network range. So the first range would be 216.21.5.0 through 216.21.5.31, and follow this pattern all the way down until you meet the requirements. So if your heart does so desire, you can assign the first range to Arizona. So we have enough network ranges, enough subnets to address Arizona, California, Florida, and last but not least, do not forget the WAN links. In this case there are 2. So now comes the task of assigning those IP addresses to those locations, setting up your DHCP server. We know that routers have the ability to act as DHCP, but most people do not burden the router with that task. They'll use a domain server to do that, such as Windows 2003 or 2008 server. Well, what happens if the California location grows exponentially and you need more hosts? Well, then you can slice it up again, take an IP address from that range that was given to California and create another network with more hosts. Of course, you will need a router to connect the 2 networks. Here's an example of 2 routers being daisy chained together. This is not the same as connecting 2 different subnetworks together. In this scenario here, looking at this picture, they're just looking to extend their network. So have fun assigning those IP addresses to those networks. Well, I hope this video was informative. I want to thank you for watching.